Hello, today we're in this problem called Valid Anagram 242, Easy Problem LeetCode. So let's get into it. Given two strings s and t, return true if t is an anagram of s and false otherwise. And they state that an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Okay, so what we can get from that is we can get the input and output from that. So it's good to note down. So we're going to use strings s and t, which are strings. And our output is just going to be a boolean, and we're going to say true is equal when t is anagram of s, and false is equal to otherwise not. Right. So yeah, it's pretty much it for the input and output. We can take some notes, just in case you don't know what an anagram is, which I don't know at all. They note here that anagram is basically a word that is rearranged, that has rearranged letters of another word. So what this means that need to have exactly all letters, but just rearranged. Right, so that's the like two definitions of an anagram. So yeah. So for some questions, I guess we can ask like if what is the min length of t of s and t? Basically, what is the length of our input strings? We can scroll down, or we can see here that s and t all have length of 1, the min length of 1, I mean. And then I guess a good thing to note is that the question is like what kind of characters are these? Are these like all lowercase, etc., stuff like that? But yeah, I wouldn't ask that to be honest, but it's just appeared there, I guess, in the constraints. So now that we understand the input and outputs and we have some questions, go ahead and go through some examples to kind of showcase how we do understand the problem and can continue. So let's just say s is equal to like s is equal to hello, and then t is equal to um olh olch. Oh no. So if we just go through it with our brains, we see that there's one h in both, there's one e in both, there's two l's in both, and one o in both. So we can say that this is true. All right. Let's do another example. 2, we have hello, right? Let's just say it's like jello. I don't know. So this would be false because from the get-go, we can see that this has a J. This one doesn't have a J, but this one, I mean, T has every letter that S does except for the H, right? And and uh, and S has every letter that T does, but doesn't have the J, so it's not anagram. But yeah, so we kind of do understand the problem. Well, I feel like I do. So let's just go ahead and kind of get some tools we can use to solve the problem. So one thought that comes to mind when thinking of like a word has to have exactly X letters, or they have to have the exact amount of letters, but arranged differently. Well, that reminds me of like a hash map, because we can use the keys as we can use the letters as keys, and we can use the amount of occurrences as values in a key value pair dictionary or hash map. So hash map, we can do some if statements, I guess. And then I'm not sure if we can compare hash maps. Can we compare hash maps? I don't know. And then some for loops, of course, to iterate through each letter or each word. So yeah, so let's go ahead and plan. Okay. So first thing we want to do is get user input, which we do get. And I want to initialize our variables. So init hash map. So hash map is equal to an enter dictionary. And then I want to iterate through both at the same time. Well, first off, I think it's very cool how oh, actually we should initialize two hash maps. So s hash and then have S hash and T hash, right? And then I think one cool thing we can do is we can say if length S is not equal to length of T, then we just return false because they should have the same length too if they're an anagram. So if we don't go through that case, we're just going to go through a for loop. So iterate through both at the same time. Okay. So you can say for I guess for I in range all the way up to the length of S, doesn't matter which one. We're going to basically input S and I and T and I into the hash map. Wait, how would this work? I mean, we could do. I mean, it's more confusing to me if I just do like this, but I think it's okay. So, so this is for S, and this one's going to be for T. Okay. So do populate S hash, then this is going to be populate T hash. So let's go populate S hash map first, letter by letter. So if S at I not in S hash, then we're going to put it in there. So S hash at S hash at Si is equal to 1, right? And then else if it is in there, we're going to say that S hash at S at I going to be equal to +1. And then we can do the same thing for T. So if T at I not in T hash, then T hash at the key T at I is equal to 1, and else if it is in there, we're just going to add it by 1. So T hash at T at I is equal to 1. And then in the end, can we compare? Compare both hashes if anagram? I don't know. So I don't know if we could do this, but I guess return if true that S hash is equal to T hash, meaning that they have the same characters and if they have the same amount of characters. I'm not sure if that's possible, but we shall see. So yeah, we shall see. If not, I can just like search up like how to do that, or if there's a way to possibly do that. So um, yeah, so this plan looks good. It works good. It looks good in my head when I run through it in my head. Oh, we can do it here, I guess. So H O. So there's one H, one O, then one E, and two L's, and then one H. So if you compare, they all have the same amount of letters, but they do appear in different orders, and they do have the same amount of occurrences for that specific letter. So I think this is good. I like to copy and paste my plan into my code as comments just so I can implement better. Just to run through it again, just to make sure I don't have any mistakes. So let's do that. All right, so first things first, we want to initialize our hash map. So, or hash maps. So S hash is equal to this. I wonder if I can do this. Let's see. It'd be cool if I can. That's like very Pythonic. And then first off, if the length of S does not equal to length of T, then we know that's an anagram already, right? So turn false. And if that's not the case, then we can check if it is an anagram or not. Length of S, iterate up to the length of S. And then we're going to populate populate S hash, and populate T hash. And then we want to compare, right? So that's what we're going to do. We're going to just fill in the blanks or the closed spaces with open spaces. So if Si not in S hash, then we're going to put it in there. Oops. And if it is in there, we're just going to increment it by 1. Then we need the same thing for t hash. So if if that letter at t is not in t hash, then we're going to put it in there. And if it is in there, we're going to increment it just like last time. And then in the end, once we're done with iterating through both, we're going to compare it. So return if true or false, this conditional phrase, if it's true. And I'm going to run it. Hopefully it works. I'm not sure if it does. Okay, it does work. That's cool. And then submit. And it works pretty good. So yeah, for time complexity, it's O of n, because we go through each letter once. And then for space complexity, it's O of n because for every letter we're going to put it into the hash map. So yeah.